It's my great pleasure to introduce the chairman of the session, who will in turn introduce the keynote speaker for the afternoon. So, David Strauss.
Thank you. This is the end of session 2, or the ultimate talk, and the keynote speaker. We're very privileged and happy to have Dr. Louis Uccellini here, and the title of his talk is Evolving the National Weather Service to Build a Weather-Ready Nation.
Okay, so good afternoon, everyone. And for those old colleagues back from the Goddard Space Flight Center that I've already been interacting with, it's good seeing you again. And the rest of it, and there's my carpool member, Dave Randall, still smiling. Don't carpool with Dave Randall. It's really great being here. And what I want to talk about today is the strategic goal of the National Weather Service and how it's changing what we're doing and how that factors back into the modeling community in ways that I think you'd be interested in, since we're trying to push the envelope of predictions of extreme events out into the week 1, week 2 period, even as we try to get the 24-hour forecast. All right. Brian, how you doing? Good seeing you again. Yep. So first of all, we need to, I want to just go through how did we come up with this strategic, it's a strategic outcome. There are goals built into it, as I'll show, but we made this plan outcome-oriented, and the impact it has on our workforce, fundamentally, is that your job's not over with a forecast. It's how does it link to decision makers across the whole spectrum, so that you get the results that you'd hope for. And this involves not only forecasts in a 1-day, 2-day, 3-day period now, it's all the way out to 8 days, even for severe weather outbreaks. And clearly, as you get down towards the warning mode, it has other implications. I want to review today's forecast process and then just go into when it works and when it doesn't. I'll give some examples, since the most recent one with the blizzard that almost hit New York. If you only define New York City by Manhattan Island, you're okay with this when it doesn't. If you account for the fact that Queens County is still in New York City, right, as Rick Rosen will tell you, it wasn't a bad forecast. So, the challenges, I love challenges, as people know me, and the opportunities, and then the summary. So establishing the need, I think people have seen this diagram of the Munich Re, these loss events, which are measured in terms of dollars and lives lost, and the increasing trend of that diagram really does point, and this is for the U.S., and the U.S., of course, has the largest array and the largest numbers within that array of extreme weather. So what this really reflects in some circles is the increasing vulnerability of our population and infrastructure to extreme events. So increasing population along the coastline, for example, makes them more vulnerable to a hurricane at landfall. And that has profound implications for those who have to evacuate people in the face of a landfalling hurricane. So at the same time that this has been happening, and this tracks back 20 years or so, we've improved 4 to 8 day forecasts of extreme events. So the idea here is to take these forecasts to the next level for effective decision support. Now, it's not just increasing vulnerability, we're also now starting to see the increasing evidence of the types of events that we would be warning people about. So this is from Tom Call's shop, the observed change in very heavy precipitation events. And in the eastern half of the country, we're starting to see evidence of the precip events that we do get being concentrated in extreme events. And was the 6-week winter that Boston had starting in late January. Evidence of that, if you just take that alone, you'd start having those kind of debates. But we're starting to see this trend now. And this next diagram is kind of interesting. These are these nuisance floods that usually occur at high tides. Now, I have a place in Lewis, Delaware, for the last 12 years, and I can tell you now that practically every high tide, for certain areas along the Delaware Bay, they're putting out a flood watch. All right, and so you see this 1 through 21 on the bottom axis is from the Boston to Norfolk, and then the years from 1920 to 2010, and you see this rapid increase in the number of events per year along the entire East Coast, concentrated in the Norfolk area where there's also this land change that's in part contributing to that. But this is a trend that we're seeing up and down the East Coast as an example. And of course, when we have now these extreme coastal storms, we're working with a different background signal than we were even 10, 15 years ago. And everybody focuses on the snow over land, but that storm I just referred to also had major coastal flooding, and people felt more confident in putting that out because of this background state. So recognizing that we have this increasing vulnerability and that our forecasts really do matter, we developed this strategic outcome. Becoming a weather-ready nation is about building community resiliency in the face of increasing vulnerability to extreme weather. So we want them to be ready, responsive, and that responsiveness, if they take the right action, leads to increased resiliency and faster recovery times, et cetera. One of the areas that this plays right to us, of course, is better forecasts and warnings. The other aspect of this is ensuring consistent products and services, and this has been a major problem in the National Weather Service, given our range of offices from the central to the local forecast offices. So we were reviewed by the National Academy of Public Administration. They did a survey of our users, our customers, our partners, and consistency was the number one issue that they raised, not accuracy, consistency. So that's a very important part of what we need to focus on in terms of decision support, and we're working our way towards impact-based decision support services, which includes embedding our folks in emergency operations centers, and we're incorporating social sciences in terms of how to message these forecasts and warnings to get the hoped-for results. With respect to the strategic goals, we worked on a strategic plan that builds into this outcome. By the way, when we were reviewed by that NAPR group, they said it was the best strategic outcome they've seen in a government agency, and then they kind of pointed their finger at us and said, you can't do it alone. So we've been mapping into emergency operation communities in the whole spectrum from local to national, other groups. I won't go into all the details, but clearly this is a strategic goal or outcome that others are resonating with and working with us on. In our strategic goals, we recognized that we needed an interdisciplinary collaborative approach to this weather-water climate linkage that's a fundamental basis of extending our predictions. The economic productivity one is a link to our private sector. They tailor products in ways for specific users that we just basically wholesale our data to, and that's working well. And then the enable, that action verb, focusing on ecological forecast systems, the work is actually being done in OAR and in National Ocean Service, but they're doing the work on our computing systems. They're linking to our models as they move out, and they're now releasing their products through our forecast offices. So they're not developing an infrastructure to even distribute and link with decision makers. So when they first started this, they were working out of labs and getting very little connection. As soon as they worked out of our forecast offices where we have all these connections established, they had like 400% increase in the access to things like harmful algae blooms. And GLERO, the Great Lakes Environmental Research Lab, is working on this Lake Erie type problem, which knocked out drinking water for 50,000 people without warning. We couldn't tell them when it was going to happen and when it was going to end. And you can see that's one of the forecast opportunities I think we have, and I'll get to that at the end. Of course, with respect to our workforce, if it's interdisciplinary, we're getting into other non-traditional areas. We're looking at a whole different trade. I just came out of an annual operating plan meeting and a whole training section on how to get our existing workforce spun up in this interdisciplinary mode is a major challenge for us. So this is our forecast process. It's really quite simple. Observe, central processing. In our country, we have central guidance from national centers. I think people are more familiar with those than the fact that we have these local forecast offices spread all over the country. And the touch points for the emergency operation centers, for the emergency management community, is principally through these local offices. And then disseminate decision support, the response and feedback. We have a very strong program now in science and technology integration. I'll just note that one of the things I've worked on in 2 years, I've been the director of the Weather Service, is to simplify our budget process, which was nearly incomprehensible. And so now I have 5 basic budget categories. It took 2 years to get through. It's all approved. All our money now is flowing this way. I have an observation portfolio, central processing portfolio, analyze forecast support, dissemination, and science and technology integration. And by combining it this way, we discover things like we have $120 million in science and technology integration that probably wasn't managed the best way before this. So a lot of opportunities now to really focus that on improving various components of this forecast process. Now, everybody in here knows this, but it's worth repeating that everything we read, hear, and see about climate, weather, and water forecasts is running through those computers, is running through that central processing. There are 4 essential components. I'm always asked to choose between a satellite and a modeling group, a modeling and a computing upgrade, and I just don't play that game. I just go right to this and emphasize that we need a balanced approach on these components. We ingest about 2 billion observations per day, principally satellites. Data is filling those large numbers. The data assimilation and modeling and the science behind that is extremely important. Try explaining data assimilation on the Hill. If you can do it in 3 sentences or less, I need you, okay? Supercomputers, you'll see we've just made some major advances in there, but that was our weakest link up until about a year and a half ago. And then forecaster skill. The forecasters are working with these models. Remember, if you're doing the decision support, those folks want to make a phone call. They don't want a computer answering the phone, right? If they're going to close down the subways of New York, close down the highway systems in states before the first flake of snow hits, they're talking to people, all right? So we need to know how to communicate that certainty and uncertainty, and that's one of the areas that we need to build up our skill levels. Now, this seamless suite of products just traces back to Hans Liedtma. And the idea is as you work your way down from season to months to week 2 to week 1 to days to hours, theoretically you'd have more certainty in the forecast. When you release a warning, you're telling your customers you're certain it's going to happen, so it converges down, whether, in your gut, you kind of worry about it, right? But that's what it's conveying. The point I'm trying to make here is that if I were to show this graph 15 years ago, there would be no ensemble models on this diagram. So we've had almost a complete transformation into not only ensembles, but multi-model ensembles with partnerships providing those multi-models. So for the North American Ensemble Forecast System, that's us, the Navy, and Canada. Okay, and we have a full exchange and run through those cycles. We have a national multi-model ensemble which involves us, Canada, I'm going to forget somebody, NCAR, Goddard, GFDL, all right? So it's not that we have to run the models internally. We have an international multi-model ensemble in the climate that involves the European Center, UK Met, Meteor France, and us. So we've pulled this together, and we're even working these multi-model ensembles now down into the short-range forecast, that high-res rapid refresh, that HRRR. There's an ensemble version of that now that's being tested through the research community here in the United States. And you see that this whole spectrum of forecast is driven by ensembles, and I can tell you that the forecasters in our national centers and many in the local forecast offices are relying on ensemble forecasts today in ways that they just weren't doing before. And of course, we have diagrams like this to show why it's important. The GFS has its skill level drops off below that magic 0.6 number for that 500 millibar anomaly correlation score at about 8 days. We add a full day from the GFS ensemble forecast system, and then you add about another half a day with the multi-model ensemble, the NAVES. So, and the consistency aspect, we're seeing less run-to-run, cycle-to-cycle perturbations in our forecast for most cases, not all, because of the reliance on the ensemble. So it's not just pushing the envelope of predictability here, but it's also bringing consistency, the run-to-run consistency, which is so important when you're embedded with the emergency management community. With the computers, we've had a major breakthrough, finally. This took a lot of work. But this is a scale from left to right from 2000 to 2015. And the blue represents the increases we had in our IBM system. This is per computer. Remember, we run 2 computers simultaneously. We have guaranteed backup of 15 minutes on our model suite. We're still, when we went to 776 teraflops, in January, we're still way behind the European Center, and we used the Sandy money that we were finally able to get through. IBM teamed up with Cray, and by November of this year, we'll have 2 computers, each 2.8 petaflops. So this will be a new era for us, and this not only has implications for our operational suite, which is also being reviewed. We have the meeting in August with the outside community coming in to review our entire model suite, but it also provides us what I believe we need for the R2O part of the picture. So those who want to work with our operational models and work with our operational ensemble systems and tell us about the optimal number that we should actually be running, I think we'll have the computing capacity to do something like that. We're also working towards computing upgrades. In January 2015, 14 days before that New York City event, we upgraded the GFS to 13 kilometers out to day 10. We got upcoming model upgrades, and the biggest one here is that we'll finally be into 4-dimensional data assimilation by the end of this calendar year. It'd be the 4D and sum and common filter, which is actually being led by the research community outside of NCEP. It's really coming through the Thorpex program, it has its roots in there. Yehania's persistence, her bets, she won. It's right there, okay? So it'll be 4D and sum and common filter be in by the end of this calendar year. So that's what I think everybody in this room has a real comfort level with. You probably could ask me 1,000 questions on it, and I'd probably be able to answer about 80% of them, all right? I've been out of the research community too long. So this is the last mile, though, and this is where the rubber meets the road for decision support. You've got to establish partnerships well before an event. They've got to trust you, right? They've got to trust your products. They've got to understand you when you're trying to explain certainty and uncertainty, because they got to make decisions knowing that they're never going to get a perfect forecast. The high impact means that we're actually bringing products that are mapped directly to the key decision points. All right, so you don't see this in the newspapers, you don't see this on television, but for aviation, for emergency management, for hospitals, et cetera, they have key decision points. If you cross a threshold, they're taking action. So you better have some level of confidence and be able to explain it. And then you got to use multiple communication paths, and the social media certainly is part of this. We have NWS chat with our partners, the media, and the emergency, so they can see us working towards a warning situation even before it hits the streets. So when does it work? So let's take a severe weather example. I could have used winter weather here, but it's 6 and 5 and 4 days in advance is when FEMA is making their decisions, because they pre-position assets before a storm. So their decisions are based entirely on a forecast. Right? And in winter situations, before the storm's even forming, right, as an example, and even in a severe weather situation. In a day 3, 2, and by the way, that means you need some kind of credibility in days 6, 7, and 8, because they're not just flipping a switch at day 6, okay? In days 3, 2, and 1, you got the regional and local folks gearing in, focusing in, and it's more than just the emergency management community at this point. It's all of these local and regional organizations that help organize schools, hospitals. You know, you can imagine those loosely coupled type. You're working with them as well. And then as you get to the event itself, there is a response when a certain, they see it for some people, they hear your warning, etc. So that last mile is extremely important. And it's that last mile we have probably the least understanding in terms of how people are going to respond. And during this whole spectrum, people's evaluation of risk and their risk preferences change. So you might not get the same response you think you were going to get even as you're approaching that day 1 to the outbreak itself. In the case of where it really worked, this Midwest tornado outbreak, you see in day 4, we were out looking for the possibility of severe weather. As we moved through days 3, 2, and 1, that shifted slightly to the west. Focused in on Illinois and Indiana, just south of Lake Michigan. You see where all the watches went. Those go out hours in advance, covered mostly all the events, and you see that severe weather outbreak basically mapping directly into the outlook 12 hours in advance. I can tell you when I went to the University of Wisconsin, you're nowhere near this, okay? We do some of this 4, 5, 6, 7, 8 days in advance now. Right. But the real key thing here was this outbreak occurred on a Sunday. It occurred during church services. It was known that this was going to occur late morning. This was not a late afternoon event. The local models that we were running showed that these convective cells were going to pop late morning. We got that information out on Saturday. So people were sitting around, the story goes, and you hear these from different mayors, that people were praying in church, they had their cell phone in their hand. And there's this wireless emergency alert that you have, right? It's all GPS in it. And this is coming right to them. So if you're getting this, it's coming at you. And people stopped sermons, they stopped parts of it, and they all took shelter. There were a number of churches hit. And this was also happening in trailer parks and things like that. People's lives were saved through this last mile. This is a net result of the outcome of the meetings we had after the 2011 outbreaks in Alabama and Missouri that killed hundreds of people. We had this thing outlooked, we had it watched, we had it warned. Hundreds of people lost their lives, okay? We focus on the last mile. So this had worked really well. Then you get to the storm in February of 2014, not this February. This is a nice example. Day 7, I left 6 and 4 out just to save space, but from day 7 on out, we were predicting a low off the east coast of the United States. This was a tremendous forecast 7 days in advance, based entirely on ensembles. And the forecasters in WPC, the Weather Prediction Center, have access to the European Center ensembles, NAEFS, UK Met, not the UK Met ensembles, they have the UK Met because of course of resolution. Canada, separately, we had the Navy ensembles. All right, this is where they came, that's where this forecast came from. They used the short-range ensemble forecast system to do probabilistic forecast of precipitation out at day 3, 2, and 1. Very consistent forecast here. This is where the snow actually occurred. Another interesting aspect of this, we can now map directly into key decision points for operations of airports. So if you get high impact with 3-hour snowfall rates or freezing rain or visibility, it turns red. This is the 3-day forecast for national. There's the 2-day. There's the 1-day. Before the first flake of snow, they cancel a third of the flights. All right? And you see there are other airports on here too. Some of the airports, all the airports in the DC area had that focused red. So they were, the flight planning for the whole mid-Atlantic region was severely affected. But the airlines will tell you, don't get the planes in there and get them stuck at an airport because it'll take them longer to recover. So a third of the flights canceled. Okay, when it doesn't work. So let's get to that New York City sort of event. This is the snowfall amount. So we had, and we can't see the actual amounts, but in the black areas, there was in the 2 to 3 foot range that we were talking about, 2 feet on Long Island up to southeastern New England. Oh, and a very strong gradient over New York City, okay? The media capital of the world. If you blow it in New York, you get embarrassed. If you blow it in Washington, it's more than embarrassment. Just point that one out. So, got it. So, we look at this, day 7, 6, 5, 3, 2, 1, down to the analysis. This is a great forecast, 7 days in advance. Then we get to within 36 hours, and I can tell you that we were struggling with the snowfall amounts over New York City. And the GFS, which was 14 days old in the operational world, even though we had forecasters working on the assessment activity, they're seeing it, it's like going from spring training now to the real deal. It had it focused from Long Island up to New England, but the European Center, which if you read the MAP, that map thing, you can tell we got forecasters that the only model I ever look at is the European Center. Well, they happen to be looking at it here, and there it is. You know, it was putting out, and again, we can't read it, but it was putting out enough precip to put about 2 to 3 feet of snow over that part of New York as well as Boston. There's the problem with the European Center model for this case. It did one of these loop backs. It overdeveloped. It built up the higher pressure to the north and a definite shift to the left, and it brought the moisture in for a longer period of time. Now, our forecasters took an ensemble system which had 25 members of the European Center, 25 members of the SHREF, which also, our short-range North American model also had a tendency to put heavy snow over New York City. So it confirmed the European Center. So the 90th percentile of snow amounts was in the 2 to 3 feet range for New York City and New Jersey. So that's what our forecasters went with, 2 to 3 feet of snow. And you can hindcast all you want, all right? They were working with ensembles. This is what they came up with. Now, this is the unscientific part of the talk. I had to get on to you. I could see this was not going to go 2 to 3 feet by the middle part of that day. Most of the snow occurred overnight, and that it was, even as we were watching the shift. That forecast behind me was from Chad Myers, who was just basing his forecast not on the deterministic GFS, but on the ensembles from the GFS. And see that gradient right over New York? So I was trying to get Wolf's attention to his own graphic, and I was trying to play it down, and he says, well, you know, I was saying 2 feet, and I says, well, you might get more in the bands, right? Because, you know, these snow bands put out the feet. And he goes, more? You mean like 4 feet? And I go, no. So for those of you who think it's easy communicating this stuff, I invite you the next day. If I ever get a call from Wolf Blitzer, you come with me. I'm going to stand there and watch how you do it, and I'll learn from you folks. Okay, the other challenge is how are you measured? From the emergency management perspective, this was a total success, okay? That quote up there is from the New York City emergency manager, Joe Esposito. What they're pointing out here, 0 lives lost in a blizzard that affected over 40 million people. 0 lives lost, okay? And you see the roads here, they closed the roads down. They were open for business 18 hours later versus in 2013 where it took them 3 days to recover. Okay, so from their perspective, what's the problem, right? We don't know how to put metrics to this, but this is what happens when you get into this building a weather-ready nation. We're going to get measured differently. Now, I read all the emails on MAP, and it hurts me, and sometimes I'm grinding my teeth, but this is where the rubber meets the road. Okay, challenges and opportunities. This grand challenge, I think everybody knows about it, knows about the MJO. There's predictability, there's the skill gap. We're trying to address this in the operational community while this is percolating as a research. So we're trying to work in parallel with you. We understand the skill gap in weeks 3 and 4. I went through the papers. I was delighted. I found some time I could read science papers. And when I didn't understand them, I called up Jim and told him, hey, clear the cobwebs out of my head. All right? So the idea here is that people are recognizing episodically that there's predictive skill, and we've got to work with this. I can tell you that the requirements we're getting now, we're getting into this 1 week to 1 month, we're getting 30-day requirements for ice forecasts for the Arctic Ocean. When is it going to freeze? When is it going to melt? We need to know 30 days in advance. Water resource people, 30-day forecast. So the people who are making key decisions are actually trying to force the envelope here in that period of time. So we're stepping up to it. We're supporting the 3 post-Thorpex projects. We're operationalizing the NMME. I couldn't stand here and give a talk. Jim would pull the plug out of me right now. We're extending the North American ensemble forecast system to 30 days. We're going to calibrate the CFS in the weeks 3 to 4 time frame to see if we can start bridging that gap. I've told you about, well, we're going to do we are doing these coupling. We got to fully couple these models. The big news here is they got $5 million in the 2016 budget. It's on the Hill. Go fight for it. I can actually talk about it, right? It's in the president's budget. And then $4 million for OAR. So we're trying to build up our capacity here in this time frame to address the requirements that are coming at us. I've mentioned the grand challenge. I won't have time to go into this. We have a lot to learn. This is in communicating uncertainty. We don't even know about the social science aspects that we have to come to grips with. This shifting risk preferences is really important. We don't know how people are going to react as we approach an event and we give them longer lead time. Like in tornadoes, we give them 45 minutes to an hour. We thought they would shelter in place. What are you kidding? They're getting in a car and getting out of there, or if their family's over there, they're driving to their family, okay? It's the worst place to be. So how are we going to deal with things like that? And with the media, and it's not the on-air forecasters, by the way, it's the general manager, it's the producer. How do you get them to agree to put probabilistic forecast or communicate uncertainty on an air? They want a black and white answer for their viewing public. Okay, ecological forecast systems. This is, I think, an opportunity we should all embrace. We can predict these precipitation, soil moisture, runoff forecasts, water temperature, air temperature. We can do harmful algae blooms now. Hypoxia is in the Vibrio. There are some people actually predicting the Vibrio outbreaks in various bays along Florida coast and along the East Coast. We're experimenting with beach quality forecasts. You want to know what's in that water before you jump in. This is all coming to health vectors. So the Office of Science and Technology Policy for the President is actually forcing us into prediction for health vectors. That's a good place to be. So we're working that. Okay, last slide. I think the vision's becoming a reality. I see this not only in the outcomes, I see it in our workforce. They're embracing this. 15 years ago, they weren't. When we were developing strategic plans, the job ended with the forecast. We've shattered that, okay? We're moving forward and beyond the basic weather forecast. We're providing impact-based decision support services. We've got the computing capacity. We've got the platform now to work with the research community. We're recognizing the need to incorporate social sciences. We're just on the front end of that, and that's not going to be the first thing cut from our budget ever. That and training is locked in. And we're addressing these shifting risk preferences as an extreme event unfolds. The health vectors is really an exciting place. This is where I go to these meetings and learn something new, so that keeps me going. And then I think we're positioning ourselves to work with the entire weather, water, climate enterprise to address the opportunities ahead. I have been able to secure a small amount of money for the research community. We've built that back up. We're working more closely with OAR now in their call for proposals, and there's a bill on the Hill being developed for the weather research that we're still not quite there yet, but that offers great opportunities for us. Thank you. Dennis?
Is going the last mile helping you to convey the fact that weather forecasts actually come from NOAA rather than from CNN?
Well, for the people who are making life savings decisions, that's all they'll depend on is a forecast coming from us. They know that. We have to serve the entire community. Our effort with the media is to try to ensure some kind of consistency in the forecasts and warnings. So that's the challenge that we're working with the media along those lines. In terms of branding our forecast, it becomes a hard thing to do. I mean, even just trying to work it through the laws is not as easy as you might think. So I think we have enough people now in the media out there that are actually emphasizing how these forecasts come from us.
Lou,
Yeah.
I've got the mic, so
Oh, there, Tim, I was wondering where you were.
I'm here. So nice talk and everything, but I wanted just to pick up specifically on your frustrations with the media.
Yeah.
Because as an outsider, i.e. from outside the US, I kind of sometimes look with some envy, actually, at how, in things like hurricane forecasts, you've got over to the public the notion that the tracks of hurricanes are not certain, and you produce these nice cones of uncertainty. I mean, I often use in my talks some, I don't know, ABS or one of these media outlets showing these ensembles of hurricane tracks, and I say, why the hell can't we do this in Europe? This is exactly what we need. And then secondly, I mean, the whole concept of probability of precipitation is something that's second nature to people in the States. So why, given that you have this, I would say, advantageous almost start in communicating uncertainty and probability, why is it so difficult then to apply it to something like this snowstorm, where you express some frustration?
The problem with the snowstorms is that they exist longer in the models than they do on TV. In other words, we can be talking about that East Coast storm for 7 days, and it develops, comes up the coast, and is gone in 18 hours. Okay? So what are you mapping it against? A track of something that's not there. And for hurricanes, we're actually finding it's easier. They've got the cloud mass, they can see it, they register some level of risk. This is what the feedback we're getting. With a hurricane, that happens. With a snowstorm, they wait. They wait. The other aspect of it is that funnel for the hurricane actually has worked against us in certain ways, because people just look at that track, and if that area doesn't cover them, they don't think of the risk outside of that area. So we have to communicate that on top. And for Sandy, we thought we were being really successful, because they did evacuate a number of people and all that, but the post-mortem analysis from independent people like various universities have gone on and surveyed a lot of people up and down the coast. Even right up until the end, the very time before the surge came up, people were worried about wind, not water, immediately along the coast. No matter how we were communicating, from Thursday to Monday, we were storm surge. So they looked at our wind graphics, and that's all that registered. So now we have to come up with graphics for storm surge, which people have been telling us for a number of years, and we're doing it now, to try to convey that. So they got to be able to, I guess, my best answer right now, and it's based on maybe 25% knowledge and 50% gut and 25% I really don't know, but I think they got to be able to visualize it for it to register. So that's what makes it hard for the East Coast storm.
Yeah, thanks for the update, Louis. I have sort of two quick questions, maybe they're related. You mentioned the Navy and the interactions with the Navy and the Canadians and so on. Where's the Air Force?
Oh.
And why don't they use your products? And
They do.
the second question is, what about outreach to the research community? And can't you make better use of the research community in your advances and so on?
Yes. So there are the co-chairs, or the ex-co-chairs of the review for NSEP, and we are attempting. So your last answer is we're attempting to do that. Now, that's why we're building up our resource pool, because money talks, right? So if we can get the money out there through us, and that you use our stuff to do your research with, some of it can come back faster, because it's the speed of the R2O as well. And that's what we're trying to set up. So we actually now support our operational code on 4 different research computers. And we have programmatic funds that flow through the Joint Center for Satellite Data Assimilation from NASA and NOAA to support the research community. And part of that money is what's developed the 4D and Salmon Common Filter system, okay? John Derber was a co-investigator on that. He was not the PI, okay? So we are doing that. Can we do more? You're right. I mean, absolutely. I think we've got a gold mine in ensemble models. But tell us, how to make it better, how to optimize that, what do we have to do to extend? So Air Force, I can't tell another agency how to operate. I can't tell another agency how to spend their money. It's against the law, okay? But I can tell you that they do use our forecast. I can tell you that the letter that was just sent out decreeing that they'll use one system was leaked by people in those forecast offices, not by any of us, because they're upset because they know they have to use a whole range of models to make the forecast that they're making. So that's all I can say at this point. But we have a great partnership with the Navy, and I can tell you one of the areas that I know people out there think that we got to develop all our models internally or we don't run them. We're now running the Navy Ocean model, HICOM model. We're running their data assimilation system, and we're going to be running their ICE model starting this fall, especially for focusing on the Arctic. And Hendrik Tolman will tell you that we saved 10 years worth of effort on each one of those decisions. So.
We'll thank the speaker again. And